This is Stephen Brower from Raton Valley Community College. This is meant to be a chapter overview for Stallings Chapter 2. So the performance is one of the things that is looked at. This is from a processor point of view. And one of the things initially looked at are what manufacturers will do to sort of increase performance of the systems that they are making. So some of the things would be talking about like the number of bits retrieved at one time, which has a basically effect of the bus width, the use of cache, as well as multiple levels of cache as a way of increasing performance, making the buses faster, and also having multiple buses. So the idea of an omnibus has a sort of a bottleneck, and but using multiple buses. And what we'll see with the computer is that the front side bus, the memory bus, is different than the peripheral based buses, which this concept's being introduced here. Its latter chapters will go into a little more details about that. A core was first mentioned in chapter 1. Here we'll revisit the idea of multiple cores. We'll take a look at different things that are being done. The MIC multiple cores that in the lab that they're getting up to 50 cores onto a processor, and then the use of the GPU, the graphics processing unit, as being an additional core is being used as well. And then a brief mention of Amdahl's law, which is, to oversimplify it, you don't get much gain beyond a certain number of processors. That will see the curve, it kind of flattens out. The system clock will be introduced in this chapter. One of the things that some computer manufacturers or computer chip manufacturers would do is increase the clock. Now, the clock is used to sort of coordinating things that are occurring within the computer system, but also the clock, the beat of the clock, an instruction is executed within that clock cycle. So we talk about a computer being so many gigahertz, it's so many billion cycles a second are occurring, which gives an indication of how many instructions are being done. Latter chapters will be looking at things like the leading and trailing edge of the curve of the clock, and has to do with timing and how things are timed out. The last topic in the chapter, we'll look at benchmark suites. And first we'll go through different means. An arithmetic mean is just the way it's computed. A geometric mean identifies really a central tendency. And what I'm about to say is not correct, but a way of looking at it is ignoring outliers. And so a benchmark is going to be a collection of programs that are in, what we're going to later look at is going to be the spec benchmark, and there's multiple languages that are used, and the applications, there actually are multiple different applications that are used, and then when this suite of programs is run, it's able to then come up with how this processor works over this suite of programs. That's about it for chapter 2.